This is the second video for curve sketching. The second problem that we had was f of x is equal to e to the x squared. And so, what do we know about that? Well, we have e to the x. So, if x was 0, then 0 squared is 0, but e raised to the 0 is 1. So we know that this is never 0, or we never have an x-intercept, basically. But whenever x is 0, we know that our y is going to be equal to 1. Okay, so now we need to take a derivative, and so we have our f prime is going to end up being e to the x squared times 2x. Okay, and so critical value, if x is 0, of course e to the x squared is going to be 1, which we just found out, but our 2 times 0 is going to end up being 0, which is going to end up being 0, so we have a critical value of 0. Okay, and so now we need to take our f double prime. So we're going to have f double prime of x is equal to we just found e to the x squared times 2x. Okay, now what you should notice about this is we're going to be using the product rule, because we have our e to the x squared times the 2x, so we're doing the product rule, which is the first times the derivative of the second plus the second times the derivative of the first, which we just found out was e to the x squared times 2x. Which brings us to here, so clean that up a little bit. Okay, and you should notice that there's several things we could pull out. We could pull out a e to the x squared and be left with 4x squared plus 2x. Okay, and out of that, we could pull out a 2x. Okay, so that's going to be our second derivative. So we could set that equal to 0. So if x was a negative 1/2, I'll take care of that one. But really just go off of 0. Oops. Because when our x is 0, that's going to make that 0. So, there you go. You can find your critical values. Alright, so now let's write down what we know. Okay, so there's what we know. We had our function. There's no x-intercept. We do have a point 0, 1. Whenever x is 0, y is going to be 1. Using 0 as our critical value. Whenever, as far as our f double prime, the good thing about the function, e to the x, it is always going to be, concave up, which is awesome. And so then our f prime, whenever we plug in values for that, anything less than 0 should give us a negative, and then anything greater than 0 is going to give us a positive. So whenever we go to graph that, okay, so I went ahead and put our point in there, 0, 1, and so since that's 0, we're never going to drop below that. But anyway, to the left of 0, we were decreasing and concave up, and to the right of 0, for anything greater than 0, we were increasing and concave up. So there you go, there's the sketched graph.